Question 2. An experiment was carried out to determine the relative molecular mass of a volatile hydrocarbon. Volatile means it's got a low boiling point. Hydrocarbon means it contains hydrogen and carbon only. It's a liquid at room temperature, liquid X. A known mass of X was vaporized at a known temperature and pressure, and the volume of the gas produced was measured in a gas syringe. Data from this experiment is shown in Table 1. Calculate the relative molecular mass of X. Well, what have we got? We've got mass, we've got temperature, we've got pressure, we've got volume, and at the bottom here we've got the gas constant R. So it's clearly pointing to PV equals nRT. PV equals nRT is the only equation we know with R in it. And so by being given the gas constant R, we know that we're using that. Pressure. Pressure should be in pascals. 102 kilopascals to turn into a lower unit of pascals, you multiply by 1,000, so that's going to be 102,000. Volume should be in meters cubed. It's in centimeters cubed. To turn centimeters cubed up into decimeter cubed, then you divide by 1,000, so that's 0.072. To get decimeter cubed then up into meters cubed, up another unit value, then you divide by 1,000 again, so it's 0.00072 meters cubed. Temperature's in Kelvin, it's already in Kelvin. If it was in degrees C, you'd add 273, but it's already in Kelvin, so that's fine. Let's have a look at the equation then. PV equals nRT, pressures in pascals, 102 kilopascals multiplied by 1,000 to get kilopascals into pascals, 102,000. Volume should be in meters cubed, it's been given in centimeters cubed. To get centimeters cubed into decimeters cubed, you divide by 1,000, 0.072. To get decimeters cubed up into a large unit value of meter cubed, you divide by 1,000, again 0.00072 meters cubed. Temperature is already in Kelvin, so that's correct, at 373. If it was in degrees C, you'd add 273 to turn degrees C into Kelvin. So now PV equals nRT, pressure 102,000 multiplied by volume 0.00072 equals N, the number of moles, that's clearly what we've got to find out, multiplied by R, the gas constant, and we've been given that, multiplied by the temperature 373. Multiply these two numbers out on the left, 7.344 equals N, multiply these two numbers out on the right, 3099.63. So N is 7.344 divided by 3099.63. So the number of moles is 0.002369. I now know the number of moles of gas X. I've been given the mass, so if I've got moles and mass, I must be able to work out MR, and that's what you're asking for. So moles is mass in grams divided by MR. I've been given mass in milligrams. To convert milligrams up into a larger unit value of grams, then I've got to divide by 1,000. So 194 milligrams up into a larger unit value of grams, divide by 1,000, 0.0194. So that's the number of grams. MR I don't know. Moles 0.002369 is the mass, 0.194 divided by MR. So MR, if I rearrange, eventually MR is 0.194 divided by 0.002369 equals 81.89. I've got to get it to two significant figures. Why two significant figures? Because I've got three significant figures, three significant figures, three significant figures, but the volume, 72, is only to two significant figures. So I find my data with the lowest significant number of significant figures. Everything's to three significant figures apart from the volume is only to two, and therefore I've got to go to two significant figures, the number of significant figures of my lowest piece of data in the question. So I'm going to round this up to 82. 82 is the MR to two significant figures. Analysis of a different hydrocarbon Y shows that it contains 83.7% mass of carbon. If it's a hydrocarbon, it only contains hydrogen and carbon, so there's 83.7% of carbon. The remainder must be hydrogen. So if you do 100 take away 83.7, you'll come out with 16.3% is hydrogen. Let's have a look at the solution then now. So we've got 16.3% is hydrogen, 83.7% is carbon. You divide by the atomic mass of each of them. The mass of carbon is 12, the mass of hydrogen is 1. So if you divide each of those, 83.7 divided by 12, 6.975, and this one turns out as 16.3. Not a great ratio, that. So you divide by the smallest, 6.975, 16.3, you divide both of them by the smallest number, so that equals 1. 16.3 divided by 6.975 equals 2.33. So the ratio is 1 to 2.33. Then you multiply by a number you're going to have to spot the number that you need to multiply by to get this fraction into a whole number. 2.33, if you multiply by 3, that equals 7. And this one equals 3. So multiply both of them by 3 and it ends up as a ratio of 3 to 7. So its simplest formula, its empirical formula, is C3H7. Now it needs us to work out, after the empirical formula, the molecular formula. So the molecular formula is its true formula. So we get this from the MR. So we look at the MR. If we add up C3H7, a carbon has got a mass of 12, so that's 36. A hydrogen has got a mass of 1, so that's 7. 36 add 7 is 43. That seems to be half 86. So the true formula is going to be double this, C6H14. You can check out his MR then equals 86 if you wish.